Welcome back. The first part of the lesson talked about sizes. This one's now talking about character sets. So we are really going to look at ASCII code, Unicode, why we group those into sequences, and what are the advantages and disadvantages over each of them. Well, there's a question for you. How is binary used to represent characters? Well, we know that the human world, the analog world, can't be processed by computers. They have to turn it into digital. And computers use binary to do that. Remember about everything boils down to ones and zeros. Everything boils down to a high voltage or low voltage circuit. We've talked about numbers, but it's not just numbers out there. There's text, there's images, there's sounds. They have to be converted into binary too. And as humans, we don't want to have to spend our time writing everything out in binary. That would just take too long. Typing out those ones and zeros would there'd be no point using computers. And sadly, when they first got going, that's what you did. You used a series of switches, flicked them on and off, entered the line of code, and then did the ones and zeros again by flicking switches on and off and doing it bit by bit by bit to get computers going. We don't want to do that now. We want to be able to just push, say, a character on a keyboard, and those series of ones and zeros are stored somewhere. And the computer needs to understand how that's done. So you push that on your keyboard, electronic signals sent or electrical signals sent, those ones and zeros are looked up, and then magically something appears on your document or message. We know it's not magic. We know it's computer science. So, to do that, every character is assigned a different binary code. And they're different. So if you have capital letters and lowercase, they're different. They're different codes. Capital A and little a have two different binary numbers, so you can tell the difference. Remember, computers are stupid. It's not just letters either, it's the numbers, it's everything you can see in your keyboard. If you look down your keyboard, everything there has a corresponding binary number. Alt keys, shift keys, control keys. I mean, look over here to the right. There's a ASCII code. This is a character set. Look at capital A there. Using 8 bits or 1 byte to represent a number. Now, if you know your binary, which you should do by now, that is 64 plus 1. Capital A is represented by the binary number 65, but the binary number 01000001. And they do go up in sequence, they do go up in numbers. So B, if A was 65, B should be 66. And that is the case. Look, 64 plus 2 is 66. So, common question. Here's a binary number. That's A. What would the binary number for D be? So what you'd have to do is work out what the binary number for work out as 65, then go A, B is 66, C is 67, D is 68, and then convert that. Or if you know what 65 is and you know that it's 3 more, then you'd add 3 onto this if you're using a binary addition. And that's what a character set is. It's used to represent every single character using binary codes. And the two you need to know about is the one you just saw, the ASCII code. And the other one is the newer one, far wider used now, Unicode. So, key term for you, character set. List of characters used to create documents and their binary codes. Let's talk about ASCII. Stands for the American Standard Code for Information Exchange. The Americans came up with it first, developed in the 60s, based on the English language. Every single character is 1 byte of data. How that's made up is 7 bits, and then there's a control bit, which you don't really use. Though extended ASCII does use all 8 bits and no control bit. Now, think back. If you have 7 bits, how many numbers is that? How many numbers can you do? So that's 2 to the power of 7. So that's 2 times 2 times 2, 7 times. And if you do that, you'll work out that the highest number you can do is 127. But remember, you can also use all zeros. So that means there is a total of 128 characters you can use in ASCII. So numbers there, you can see there, numbers 0 to 9, all the capital, lower and uppercase characters, punctuations, and there's even codes that are used there that you don't normally see, like carriage returns, line returns, printer feeds, because it's all legacy from the 60s. hopefully your little computer scientist brain is whirring there and thinking, 128 characters, is that enough? What about the Russian alphabet? The Chinese, the Japanese alphabet, Arabic? What happened there? You couldn't do that, so they'd have to use American style or English style language to be able to use computing. And clearly that's not very inclusive. So then more bits were made available, and this was Unicode, to allow different alphabetic systems to be used, such as Russian. So as I said, ASCII was limited, so that's why they had to use Unicode. And that was developed in the 80s. And Unicode, universal, something to encompass the whole globe rather than a certain subset of the globe. And without Unicode, you would not have the emojis. Reason being, ASCII, only 128 characters. Unicode uses 2, not bits, it uses 2 bytes. So you think about that. That is 16 different digits. That's 2 to the power of 16 different characters it can represent, which in this case is 65,000 characters. That's way more than any language needs in the world. And that's why then you can start using these codes to represent certain emojis, certain graphics. So thank Unicode for that. And there are bigger versions of Unicode as well. So the Unicode 2-byte system is Unicode 16, but there's also Unicode 32, which uses 4 bytes, even more characters. Bearing in mind what I've said, maybe it's your turn to have a go. How many characters can ASCII represent? If the character A is 97 in denary, what is it in binary? Give your answer in 8 bits or 1 byte. If a character A is 97 in denary, what is D in binary? Use 8 bits. Why would you use Unicode instead of ASCII code? How many bytes would be needed to store follow the white rabbit? Exclamation mark. And finally, how does an algorithm know when you sort that A comes before B? True story. When I was 15, I asked my computer science teacher that exact question, and her answer was to shout at me and going, "It just is! It just is!" When really she should have said to me, well, because, and I'll tell the answer in a minute. Pause the video, have a go, tell the answers in a sec. Right, hopefully you had a go at that. So how many characters can ASCII represent? 128, 2 to the power of 7. If the character A is 97 in denary, what is it in binary? Well, convert 97 to binary. You should know how to do this. 97 is 8 bits, remember, so have to start at the 128 columns. There's no 128s. There's 164. There's 132, so add those together. That gets you 96. So that leaves you 1 left. So that means there'll be no 16s, there'll be no 8s, there'll be no 4s, there'll be no 2s, there'll be that 1, 1. So pop that down, that answer, with 8 bits. Don't forget the leading 0 to get you 0, 1, 1, 0, 0, 0, 0, 1. This next one, more common in GCSE. Here's a number. Here's a letter. What would be a letter further or before in the alphabet? I'll ask you then to do a little bit of maths there. Well, think about it. A is 97. So and you want D, so what's B? That's going to be 98. What's C? 99. What's D? 100. Then just convert 100 to binary. No 128s, you've got a 64, you'll have a 32, that's 96, that'll leave you 4 left. So no 16s, no 8s, 1 4, then nothing's left, so no 2s and no 1s. And there's your answer, 0 1 1, 0 0, 1 0 0. Why would we use Unicode instead of ASCII? Well, because we can represent more characters. Why is that a good thing? Because then we can represent more languages. We can represent all the languages of the world, which is clearly a good thing. But we can go beyond languages. We can also use graphics type characters to represent things like emojis. Question 5 there. How many bytes? Well, we know that every character is 1 byte. So what are there? Well, there's 20 letters. There are 3 spaces. And there's 1 exclamation mark. So that's 24 characters, which is 24 bytes. And what my computer science teacher should have told me is, how does a sort algorithm know? Well, A is given a number, and B is given a higher number. It's given a number 1 more. So when it does sorts, it just compares the numbers. If a number is higher, it knows that comes after the previous letter or number. If little a was 97, little b should be 98. So that's how it knows A comes before B. I think you know what's coming next. Edmodo, quiz, representing data, characters, off you go. Once you've done that, here's your recap. Today, we finished off this second part of the lesson. You should now know what a character set is. You should now be able to describe ASCII and Unicode. You should tell us why we group the codes together and run them in sequence so we can sort them. And also, what's the advantages of Unicode over ASCII? Far more characters, all languages supported. You can support graphics. And that's the end of this lesson. Cheers.